There could indeed be a problem with mixing incandescent and fluorescent bulbs in the same circuit, especially if the ballast is not designed for this type of setup. Here are some potential reasons why a ballast may be humming loudly. Firstly, incompatible ballast. The ballast may not be compatible with the incandescent bulb. Incandescent bulbs have different electrical characteristics than fluorescent bulbs, and the ballast may not be able to handle the mixed load effectively. Secondly, frequency interference. Incandescent bulbs produce a different type of electrical noise than fluorescent bulbs. When these two types of bulbs are on the same circuit, they can interfere with each other's operation, causing humming or other noises. Thirdly, overloading. The circuit may be overloaded if the total wattage of the incandescent bulb and the fluorescent fixture exceeds the capacity of the ballast. This can strain the ballast and lead to humming. Fourthly, loose connections. Loose connections in the wiring or the fixture can also cause humming. When the electrical current is not flowing smoothly, it can create vibrations that manifest as a humming sound. To resolve the humming issue, consider the following steps. Firstly, check the ballast. Ensure that the ballast is designed to handle both incandescent and fluorescent bulbs. If it is not, it may be necessary to replace it with a compatible one. Secondly, separate the circuits. If possible, separate the incandescent bulb and the fluorescent fixture onto different circuits. This will eliminate the potential for electrical interference. Thirdly, verify connections. Make sure that all electrical connections are tight and secure. Loose wires can cause humming. Consider a different fluorescent fixture. Some fluorescent fixtures are designed to be more compatible with incandescent bulbs. Consider replacing the existing fixture with one that is better suited to mixed load circuits. If the humming persists after trying these steps, it is recommended to consult with a qualified electrician for further diagnosis and repair. When dealing with electrical systems and lighting circuits, it's important to understand the potential interactions between different types of lighting technologies and the components that power them. The ballast in a fluorescent lighting system plays a crucial role in regulating the voltage and current supplied to the fluorescent bulb. It acts as a control device, ensuring the bulb receives the correct electrical input for proper operation. A humming sound emanating from the ballast is often an indicator of underlying issues that need to be addressed to prevent potential problems and ensure safe and efficient lighting. In the case of a three-way lighting circuit with a mix of incandescent and fluorescent bulbs, several factors can contribute to the humming sound. Firstly, the compatibility of the ballast with both types of bulbs is a primary consideration. Ballasts are typically designed and manufactured to work with specific types of lamps, whether they are fluorescent, high-intensity discharge, or other types of lighting. If the ballast is not designed to handle both incandescent and fluorescent loads, it may struggle to provide the correct voltage and current to both types of bulbs simultaneously. This mismatch can result in the ballast operating outside of its intended parameters, leading to the generation of audible noise like a hum. Secondly, the different electrical characteristics of incandescent and fluorescent bulbs can lead to interference when they are in the same circuit. Incandescent bulbs operate by heating a filament until it glows, emitting light as a byproduct of this heating process. Fluorescent bulbs, on the other hand, use a gas-filled tube and electrical discharge to excite phosphors, which then emit light. These two processes create different types of electrical noise and electromagnetic interference. When both types of bulbs are on the same circuit, the electrical noise can interact, leading to disruptions in the smooth flow of current and potentially causing the ballast to hum as it tries to compensate for these fluctuations. Thirdly, overloading the circuit is another potential cause of the humming ballast. Every electrical circuit has a limited capacity determined by the size of the wires and the rating of the circuit breaker. If the total wattage of all the devices on the circuit, including the incandescent bulb and the fluorescent fixture, exceeds the circuit's capacity, it can strain the ballast. The ballast may be forced to work harder to maintain the proper voltage and current, leading to overheating and humming. In severe cases, overloading can also trip the circuit breaker or even pose a fire hazard. Fourthly, loose electrical connections can also contribute to the humming sound. Loose connections create a resistance in the circuit, which can cause the current to flow unevenly. This irregular current flow can lead to vibrations within the ballast, which manifest as a humming noise. Loose connections can also cause heat buildup, which can further degrade the ballast and increase the risk of electrical problems. To diagnose and resolve the humming issue, several steps can be taken. Firstly, carefully examine the ballast to determine its compatibility with both incandescent and fluorescent bulbs. The ballast should have a label or markings indicating the types of lamps it is designed to operate. If the ballast is not rated for both types of bulbs, replacing it with a compatible ballast is essential. Secondly, consider separating the incandescent bulb and the fluorescent fixture onto different circuits. This will eliminate the potential for electrical interference between the two types of lighting. If separating the circuits is not feasible, try using a different type of fluorescent fixture that is designed to be more compatible with incandescent bulbs. Some newer fluorescent fixtures incorporate features that minimize electrical noise and interference, making them a better choice for mixed lighting circuits. Thirdly, meticulously check all electrical connections in the circuit, including the connections at the ballast, the fixture, and the switches. Ensure that all connections are tight and secure. If any loose connections are found, tighten them carefully to ensure good electrical contact. Fourthly, check the wattage of all the devices on the circuit to ensure that it does not exceed the circuit's capacity. If the circuit is overloaded, reduce the load by removing some of the devices or by splitting the load onto multiple circuits. Consider using energy-efficient LED bulbs as replacements for both the incandescent and fluorescent bulbs. LED bulbs consume significantly less power than traditional bulbs, reducing the load on the circuit and potentially eliminating the overloading issue. Furthermore, LED bulbs are more durable and have a longer lifespan, reducing the need for frequent replacements. When working with electrical systems, it's crucial to prioritize safety and follow proper procedures. Always turn off the power to the circuit before working on any electrical components. Use appropriate safety gear, such as insulated gloves and eye protection. If you are not comfortable working with electricity, it's best to consult with a qualified electrician for assistance. An electrician can properly diagnose the problem and implement the necessary repairs to ensure the safety and reliability of the lighting system. They can also advise on the best types of lighting fixtures and ballasts for specific applications, taking into account factors such as energy efficiency, light quality, and compatibility with existing electrical systems. Furthermore, it is important to be aware of and comply with all applicable electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. An electrician can ensure that all work is performed in accordance with these codes, minimizing the risk of electrical problems and ensuring the long-term reliability of the lighting system. Remember that electrical systems can be complex and potentially dangerous. If you are unsure about any aspect of working with electricity, it's always best to err on the side of caution and seek professional help. By following these guidelines and taking the necessary precautions, you can safely and effectively address the humming ballast issue and ensure the proper operation of the lighting system. Addressing the humming ballast issue is not only important for resolving the annoying noise, but also for ensuring the safety and efficiency of the lighting system. A malfunctioning ballast can consume excessive energy, leading to higher electricity bills. It can also generate heat, which can damage the ballast and surrounding components, potentially leading to a fire hazard. By addressing the problem promptly, you can prevent these potential issues and ensure the long-term reliability of the lighting system. In addition to the steps outlined above, there are a few other things to consider when troubleshooting a humming ballast. Firstly, check the age of the ballast. Ballasts have a limited lifespan, and they can become noisy or malfunction as they age. If the ballast is old, it may be necessary to replace it even if it appears to be working properly. Secondly, check the type of ballast. There are two main types of ballast: magnetic and electronic. Magnetic ballasts are older and less efficient than electronic ballasts. They are also more prone to humming and other noises. If the fixture has a magnetic ballast, consider replacing it with an electronic ballast. Electronic ballasts are more energy efficient, quieter, and have a longer lifespan. Thirdly, consider the location of the fixture. If the fixture is located in a damp or humid environment, the ballast may be more prone to corrosion and malfunction. In this case, it may be necessary to replace the ballast with a moisture-resistant model. Furthermore, it's important to understand the different types of fluorescent lamps and their corresponding ballasts. There are several types of fluorescent lamps, including T12, Tate, and T5 lamps. Each type of lamp requires a specific type of ballast. Using the wrong type of ballast can damage the lamp or the ballast, or both. Before replacing a ballast, make sure to identify the type of lamp that the fixture uses and purchase a ballast that is compatible with that lamp. The lamp type is usually printed on the lamp itself. In addition to replacing the ballast, it may also be necessary to replace the lamp. Fluorescent lamps also have a limited lifespan, and they can become dim or flicker as they age. Replacing the lamp can improve the light quality and reduce the strain on the ballast. When replacing a fluorescent lamp, be sure to dispose of the old lamp properly. Fluorescent lamps contain mercury, which is a hazardous material. Do not throw fluorescent lamps in the trash. Instead, take them to a recycling center or a hazardous waste disposal facility. By following these additional tips and taking the necessary precautions, you can effectively troubleshoot and resolve the humming ballast issue and ensure the safe and efficient operation of the lighting system. The information provided serves as a guide for troubleshooting a humming ballast and understanding the potential causes and solutions. Always prioritize safety and consult with a qualified electrician if you are unsure about any aspect of working with electrical systems. A qualified electrician has the expertise and experience to properly diagnose and repair electrical problems, ensuring the safety and reliability of your home or building's electrical system. Remember that electrical work can be dangerous and should only be performed by qualified individuals. Never attempt to work on electrical systems if you are not properly trained and equipped. By taking the necessary precautions and seeking professional help when needed, you can protect yourself and others from electrical hazards and ensure the safe and efficient operation of your electrical systems. The importance of proper grounding in electrical systems cannot be overstated. Grounding provides a path for stray electrical current to flow safely back to the source, preventing electrical shocks and reducing the risk of fire. Ensure that all electrical outlets and fixtures are properly grounded. If you are unsure about the grounding of your electrical system, have it inspected by a qualified electrician. Surge protection is another important aspect of electrical safety. Power surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Install surge protectors on all electrical outlets that power sensitive electronic equipment. Consider installing a whole-house surge protector at the main electrical panel to protect all of the electrical devices in your home from power surges. Regular inspections of your electrical system are essential for identifying potential problems before they become serious. Have your electrical system inspected by a qualified electrician every few years. The electrician can check for loose connections, damaged wiring, and other potential hazards. Early detection and correction of electrical problems can prevent costly repairs and ensure the safety of your home. Remember that electrical safety is a shared responsibility. Be aware of the potential hazards of electricity and take the necessary precautions to protect yourself and others. Educate yourself and your family about electrical safety. By working together, we can create a safer environment for everyone. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work or troubleshooting. Electrical codes and regulations vary from location to location. Ensure that all electrical work complies with the applicable codes and regulations in your area. Electrical systems are complex and potentially dangerous. Never attempt to work on electrical systems if you are not properly trained and equipped. By following these guidelines and taking the necessary precautions, you can ensure the safe and efficient operation of your electrical systems and protect yourself and others from electrical hazards.